Strategy Management Series. Video number 109 Strategy Formulation. Step 7 Strategy Evaluation. Game Theory, Simultaneous Moves. Welcome back to the Ready MBA series on strategy management. In our previous sessions, we delved into strategy evaluation, the crucial seventh step of the strategy formulation process. This stage entails scrutinizing potential strategies for their impact, benefits, costs, and resource requirements. We also explored the ways in which competitors' reactions can affect the financial viability and overall appeal of a strategy. We also outlined a detailed step-by-step process for anticipating competitors' responses and developing suitable contingency plans. One key method for predicting competitors' moves is game theory, and in this episode, we continue our deep dive into this technique, demonstrating how it can be leveraged by the planning team to refine their strategic analysis. Game theory is a mathematical framework used to study strategic interactions among rational decision-makers. It's a valuable tool for understanding competitive scenarios where the outcomes depend on the choices made by multiple parties. Game theory offers numerous benefits, including the ability to anticipate competitors' moves, refine strategies, and evaluate various strategic scenarios. Planning teams can leverage game theory during strategy formulation, particularly during strategy evaluation, to identify optimal strategies, analyze competitive dynamics, and reduce uncertainty in decision-making. Game theory encompasses different types of games, with two primary categories: sequential moves games and simultaneous moves games. In sequential moves games, players take turns making decisions, with each move observable to subsequent players. In simultaneous moves games, all players make their moves without knowing the choices of others, adding an element of uncertainty. In this episode, we'll focus on simultaneous moves games. Simultaneous moves games require players to choose their strategies without full knowledge of their opponent's decisions. This type of game encourages players to anticipate opponents' moves and adjust their strategies accordingly. Simultaneous moves games are situations where players make decisions at the same time or without knowledge of others' moves. These games often involve creating a strategy that considers all possible outcomes based on the actions taken by each player. In business contexts, these games are common when companies are determining their pricing decisions, advertising strategies, product launches, investments, strategic partnerships, or bidding in auction. In all such situations, companies need to make decisions at the same time as competitors, without knowing what their actions or decisions will be like. The key to succeeding in simultaneous moves games is to put yourself in the other party's shoes and figure out the best strategic moves for both yourself and the other party. A dominant strategy is a strategy that yields better outcomes for a player regardless of what the other players do. When a player has a dominant strategy, the best approach is to follow it because it always results in superior outcomes. A common tool used to understand dominant strategies is the payoff table, a matrix that displays the potential payoffs for each combination of strategies chosen by the players. Building a payoff table. To build a payoff table, list all possible strategies for each player along the rows and columns. Each cell in the table represents a combination of strategies from the players, with the corresponding payoffs for each. For example, in a simple game with two players, player A and player B, where each has two possible strategies, X and Y, the payoff table would have 4 cells representing all possible outcomes. In payoff tables or matrices, the payoffs are assigned to the different cells for each player, and they indicate the value of reaching a specific outcome. These payoffs can be financial, like revenue or profit, or non-financial, such as market share or strategic advantage. To estimate these payoffs, planners must consider a range of factors, including market trends, competitor behavior, and customer preferences. Accurate payoff estimation is critical, as it guides the strategy formulation process. Identifying dominant strategies. To find a dominant strategy for a player, compare the payoffs for each strategy against all other strategies. A dominant strategy consistently provides a better or equal outcome than all other strategies, regardless of what the opponent does. When both players have clear dominant strategies, the combination where they intersect in the payoff table becomes the likely outcome. In a simultaneous moves game involving two players, planners must analyze all potential outcomes associated with each strategic move available to each player. For player A, this entails comparing the payoffs within each row against one another. While for player B, the comparison occurs between the columns. The dominant strategy for player A is the row containing values that are higher than those in all corresponding cells across other rows. Similarly, for player B, the dominant strategy is the column with the highest values compared to the other columns. A common misconception is that a dominant strategy always results in the best outcome compared to other players' strategies. In this example, the highest payoffs would be 8 for each player, however their dominant strategies do not lead to this outcome. In reality, a dominant strategy only needs to be better than all other strategies available to the same player, even if some outcomes are worse than others depending on the opposing strategies. In game theory, players will always adopt their dominant strategies because they maximize their outcomes in the light of other players' responses. This is true even if there might be other combinations of higher payoffs that are not part of any dominant strategy. Dominated strategies. A dominated strategy is the opposite of a dominant strategy. It's consistently worse than other available strategies. Rational players should never choose a dominated strategy, as it offers inferior outcomes. Identifying and eliminating dominated strategies can simplify the payoff table and focus attention on more likely outcomes. This simplification is especially useful when dealing with complex game scenarios with numerous strategies. When dominant strategies do not exist. In some cases, neither player has a dominant strategy. In these situations, the optimal strategy depends on the choices of others. The key is to find which player gains the best payoff from their available options and assume they will pursue that strategy. The other player can then respond with their best possible strategy, given their opponent's choice. We will examine such situations in more detail in our upcoming videos. Stay tuned. Game theory, particularly in simultaneous moves games, offers planning teams a structured approach to evaluate strategies, anticipate competitors' moves, and refine their own strategic decisions. By considering the concepts of dominant strategies, dominated strategies, and payoff tables, teams can make informed decisions during strategy formulation and reduce uncertainty in competitive environments. Let's consider a simple example to illustrate the concepts discussed previously. 1. Understanding the game and creating the payoff matrix. Assume a simultaneous game with two companies, Company A and Company B, deciding on pricing strategies. They both will decide on low or high prices simultaneously, without knowing the decision of the other. In this game, we represent it using a 2x2 matrix where Company A's choices are listed in the rows and Company B's choices are in the columns. Each cell in the matrix displays the payoff for Company A first, then the payoff for Company B, corresponding to the strategic moves made by both players at that intersection. 2. Estimating and assigning payoffs. In this game, if both companies set low prices, they each earn a profit of 7 million. If Company A sets a low price while Company B sets a high price, Company A earns a profit of 5 million, while Company B earns a profit of 15 million. Conversely, if Company A sets a high price while Company B sets a low price, Company A earns a profit of 15 million, while Company B earns a profit of 5 million. Lastly, if both companies opt for high prices, they will both earn similar profits of 8 million each. 3. Identification of dominant strategies. Now that we have our payoff table set up, let's look for any dominant strategies. First, we focus on Company A. We compare the rows of the matrix, checking A's payoffs in one row against the other rows. The aim is to see if there's a row where all of A's payoffs are greater than the payoffs in the corresponding cells of other rows. Whenever we identify such a row, it then represents Company A's dominant strategy. In this example, the row for A's strategic move of high prices shows systematically higher values than A's payoffs values for low prices. When comparing the corresponding cells in the two rows, we note that 15 is greater than 7, and 8 is greater than 5. High prices then represent Company A's dominant strategy as it offers the best outcomes for all combinations of strategic moves between the two companies. Now, let's look at Company B. We'll do the same comparison, but this time, we'll focus on all the columns. We'll compare the payoff values in corresponding cells across different columns. When we compare the values in the two columns, we see that 15 is greater than 7, and 8 is greater than 5. Therefore, setting high prices is Company B's dominant strategy as it yields the best outcomes for all combinations of strategic moves between the two companies. 4. Finding equilibrium. Once we've identified the dominant strategies for both players, we can determine the equilibrium for the game. Equilibrium is when neither player has an incentive to change their strategy, given the other player's strategy. It's like a balance point where neither player gains by changing their move. Finding equilibrium is crucial in strategy analysis because it helps us understand stable outcomes and predict how players will behave in a given situation. In our simple example, adopting high prices is the equilibrium situation as both companies will not have incentives to take a different strategy. If one of them pursues a different strategy than equilibrium, meaning adopting low price, to get a higher payoff, they can be sure to expect the competitor to follow their action, otherwise they will be worse off. And when they both eventually adopt a low price strategy, their final outcome will be lower than with the high price strategy. They will end up with 7 million profits for each instead of 8 million if they had pursued the equilibrium situation. Five. Dominated strategies. Dominated strategies are those whose payoffs are lesser than the payoffs for all of the other strategies. This means that they should not be adopted as players will be worse off compared to the other strategic alternatives. Identifying dominated strategies is helpful especially in more complex games because they can be removed from the payoff matrix, making it smaller and simpler to be analyzed. Assume that in our example, the players had a third strategic move to be considered: keep prices constant. This would change the payoff matrix from a 2x2 to a 3x3 table. The payoffs for this strategic move are described in the table. When we compare them to payoffs of the other strategies for Company A, we can notice that the keep prices payoffs are lowest across the entire row. This means that keeping prices constant is a dominated strategy because Company A is worse off by adopting it. Therefore, the keeping prices constant row can be removed from the table since Company A would not be adopting it in any circumstances. Now doing the same comparison for Company B, we can also notice that keeping prices constant has the lowest payoffs compared to the other strategies described in the other columns. So, in this case, keeping prices constant is also a dominated strategy for Company B, and could be removed from the payoff matrix. After removing both the row from Company A, and the column for Company B, the new payoff matrix is reduced from 3x3 to 2x2, becoming a simpler table to be analyzed. This simple example illustrates the benefits of finding dominated strategies, especially in more complex games where there are several strategic moves, or when a dominant strategy cannot be easily identified. And this concludes our introduction of simultaneous moves games. Thank you for joining us. Please be sure to join us in our next episode where we will present a step-by-step guide on how to identify, structure and analyze simultaneous moves games. Until then, keep strategizing. See you soon.